Hello, students. So this is where we left off last time. So today, with the second video, I want to talk about conservation of energy. So, conservation of energy means energy changes forms and it doesn't go anywhere. So, for example, let's say you have chemical energy and you turn it into mechanical energy. Or if you have potential energy, you have kinetic energy. Now, what the word conservation of energy means is that you're not going to give it more kinetic and give an object more kinetic energy than the potential energy it started with. So, same thing is true with a car. So, if you have chemical energy in the form of gasoline and you convert that chemical energy into mechanical energy, then the car is only going to move so far. This means another good example of conservation of energy. So let's say you have a piece of paper, you light it on fire. The energy released is limited to the amount of paper that you started with. That's all it is. That's all it is. So, applications of conservation of energy. We know how much energy is needed to move your car 1 mile. This is called the mile per gallon. And mile per gallon is the distance a gallon of gasoline can move your car. So, we are at a very interesting point in history because no time in the past, basically the difference between the first car and a car today is that, it's faster, safer, all those things. But cars are really starting to change quickly because of new technology. And the technology is related to robotics and satellites and camera technology. It's a lot of different things combined. So, in the next couple of years, we're going to start seeing things like self-driving cars, and that's going to mean a lot of changes in society. Now, because America has a infrastructure that's designed for cars. So, one next question, sample question: what energy conversion happens when a person hits a bell? So, energy can change forms. Energy can change forms. So it can change from different types. So the different types we saw here were chemical energy turned into mechanical energy and potential energy turned into kinetic energy. Now, let's say you have an energy conversion. What happens when a person hits a bell? So we first need to look at what the possible options are for energy. So electrical energy. No electricity is involved when you hit a bell. So mechanical energy. Mechanical energy is potential and kinetic energy. So if you had to move in order to ring the bell, that's mechanical energy. Sound energy is what's made, and light energy isn't involved here. So, what energy conversion happens when a person hits a bell? In this case, it's mechanical energy that's converted into sound energy. So, at this time, take the R1.5 conservation of energy quiz.